Hello, how are you? Vinpartuna, can you hear what I'm saying, ma'am? Okay, we will start the lesson. Hi, everyone. My name is Samyukta, and today I'll be teaching your spoken English class, but an engineering edition. So, today I'm going to teach you the different types of engineerings and some terminology and why engineering is so beneficial in our lives. Okay, so let's get started. So, today we're going to learn about engineering. What does engineering even mean? What do engineers do? So, like, what type of work do they do? We will look at the different engineering design process, the different types of engineering, like mechanical engineering, civil engineering, and what are some basic engineering like terminology and tools? So like basic engineering words. And then we'll have a short recap. And yeah, I hope everyone is doing well today and are excited for today's engineering lesson. Okay, let's get started. So let's first think about what is engineering. So engineers, they build new systems. They develop solutions to problems and they make sure the world is a better place. Like they design our laptops, our calculators, our phones, our anything, even our books too. Like when they're creating books, engineering is needed, like the machines, when you're measuring, all of that stuff does come under engineering. And we try to develop the solutions like how if a phone is broken, how can we fix it? Or like if something like when there's like a manhole or something, like how can we help cover it up or how could we help solve those problems like water issues, like irrigation, farming, engineering is needed to solve all any problems that are happening in our world. So, based on this definition, oops, sorry. Have any of you guys ever been an engineer before? It doesn't have to be anything big. It could be something small, like building blocks. Like when you're small, I'm pretty sure you guys played with something like even rocks. When you're putting rocks together, even when you're throwing rocks, I think it's one of the terms we will learn today. We kind of look at the trajectory or like the acceleration or like the arc that is made when you throw a rock. When you're throwing a rock or a ball, it's like a curve, right? A curve is kind of made. So that does come under engineering because if we're like in aerospace engineering, like space, when you're launching a rocket, you have to measure how does the rocket kind of arc or like what shape does it do when it's launched into space. So yeah, like building blocks, sorry, excuse me, or even throwing something, anything. So let's take about maybe 30 seconds to 1 minute, maybe talk to the people around you and just kind of see if you've ever been an engineer before. All right? Time starts now. Okay, that was a little less than 1 minute, but just to move on, because there is a lot to do, we're just going to move on. All right, let's go. So now we're going to look at what exactly do engineers do. So engineers do so many different things. There's way more that they do other than what I have put on my slides. Like first, they solve the different problems. Like if something is broken, like I said, like for phone, our calculator, our anything, even something in our house is broken, engineers are needed to fix those problems and fix those broken items. It could also solve any social issues as well. So going even bigger, like water problems, like water irrigation, farming, all the tools that are needed for like big and huge dams. Engineers are who that build the dam, work with the function, and also help with the water flow. So engineers help in very small problems like something simple as maybe your block building or whatever you built is broken, all the way to big water dam and irrigation problems. So they do so many different things. So going off of that, they help society as well. So like create any new roads or make any new cars or buses or motorcycles or trains, like the bullet trains that are happening right now, like the trains that move super duper fast. Those trains engineers are needed to make those trains. And now we're also going to be having like flying cars. So cars that fly in the air like airplanes. So in the not near future probably, but like a couple of years later, we're going to have flying cars as well, which is insane. It's crazy. When all of you guys grow up, who knows? You guys might have a flying car right in your house, and that is so cool. Another thing is meeting new people. This way, through engineering, right? You have chemical engineering, mechanical engineering. Like I'm a mechanical engineer right now. That's my major in college. There's civil engineering, there's systems engineering. So we'll look more into that. So you get to meet new people who come from different types of engineering backgrounds, which I think is so cool, because when you're building like a big water dam, you need different types of engineers. Like you need a civil engineer, right? A civil engineer is who builds like buildings, bridges, construction. So you need civil engineers to help build those dams. You're going to need like mechanical engineers to help with building like maybe the gears or helping with like the function of the dam. So mechanical engineers could help look at the mechanics or like how the dam works. You're going to need mechanical engineers to do that. You're going to need electrical engineers who look at the electrical components like circuits, like we'll look into more of that, any like wires, so anything wires or circuit or power or like voltage, resistance, all of that is electrical engineering, and you're going to need electrical engineers to kind of help with the circuitry or the different circuits of engineering. Okay, sorry, just 1 second, please. What happened? Bro. Confirm and go live. Click that. What? It says invalid. Oh, title. What are you? 5th grade, right? Okay. Go and make sure your Zoom video is off, okay?
Oh, my microphone's on?
Yeah. Can you close the door, please? Close the door, please! Hi, I am so sorry. I had to just quickly take care of something real quick that, disrupted our lesson. I'm really sorry about that. I promise it won't happen again. Okay, so where were you? Okay, electrical engineers. So you need all those people just to build one big dam. I hope you guys know what I'm talking about. Maybe I can just pull up a picture real quick. Like this is off of Wikipedia, which I will put in the presentation and make sure I will cite it. But this is kind of what I'm talking about. Like a huge dam, and you're going to need electrical engineers, civil engineers, all those people to help with this. All right? It's cool. So, going on, another major one is building teamwork skills. When you grow up, all of you guys will need to work with other people. So you're going to need to build those leadership skills and the strong bonding between your people and your employees, because that's the only way you're going to build these massive systems and these constructions, right? You want to make sure that you're being a leader and you're leading everyone in the right path to make a very huge and positive change in the world. And that's why I chose engineering as my major, because I love to help people, and there are so many different problems in the world that when I'm working in a team, I can help solve those issues on a bigger scale. All right, let's move on. So, a major part in engineering is the engineering design process. Okay, can you guys say it together, please? The engineering design process. Okay, so first thing in the engineering design process is first defining the problem. You want to make sure that you know the problem that you're working with. Like for instance, let's look at the dam again. Our main problem is water flow. So how the water is flowing in the system. That's our problem. And the next step is to identify the constraints, or like the different requirements in our solution, like time. Maybe you need to make the dam done by 2 months or 3 months. So time is such a huge constraint, or like a huge requirement that we need to follow. Another one is money, like the budget. We want to make sure that our solutions are both efficient and effective. So efficient, maybe using the least amount of money possible, but making it effective so it works the best. So works the best with less money. I know it's tough. Another one is materials. You want to make sure that you're having all the materials needed to build the dam, like the cement or any rods, the electrical components, and the different criteria for success. The next thing we do is brainstorming, or coming up with different solutions to the problem. So maybe you can have a drawing of one type of dam that you want to do. Or you can draw another design with a different type of dam with a different approach. Like maybe your channels, or like the ways that the water goes through, maybe it's bigger in one design but smaller in another. So it's always good to have different solutions that you want to work with. So you could also, so eventually you can create a final sketch where it kind of combines all the ideas together to make the best solution possible. The next thing you want to do is select the most promising solution. So you want to select the solution or like the sketch that you chose that's, again, both, remember, effective and efficient. So you want to make sure that that design works the best while keeping in mind the time, the money, and the different materials. The next step is prototyping or your solution. So maybe you kind of built a small kind of model of your dam. That's a prototype. So you're building like a small model just to see how your solution is kind of working. And after you build that small solution, you want to test it. So you want to make sure you're evaluating the small dam or the small prototype that you created to making sure it works properly. Because again, you want to make sure that the people are safe, right? Because if the water flow is too fast, or it could, flood. Maybe if there's another village or something nearby, it could flood the village. And if it's moving too slow, then you're not getting enough water. So you want to make sure that when you're testing, each and every single detail is being paid attention to because you don't want to mess up. You do not. Otherwise, people are going to be in trouble. You are going to be in trouble. So you want to make sure everything is being attentive. The other thing is iterating. So just because you made one solution doesn't mean you stick with it or it's the only thing. You have to keep doing it over and over and over and over and over and over and over again until it's perfect. I know it's hard, but you have to keep doing it over and over and over and over again until it's completely perfect. The other thing is, the next step is to communicate your solution or presenting it to other people. Once you made your small dam, maybe you can show it to a minister or an MLA or the central minister or anyone to be like, hey, I made this small design. What can we do? Can we implement this? Can we actually follow this? This is when you get to reach out to different people and show them your hard work. But it doesn't end there. You go back into defining another problem, because once you find a problem and you find a solution to it, I promise you, you will find another problem. Maybe right now you're working with water flow, but maybe you need to look at the environmental, what the water dam is being surrounded by. You want to see maybe there's environmental problems, I don't know, maybe there's tons of rocks or something that could block the irrigation. Maybe you first solved the problem with water flow, but a new problem came with the different rocks around the dam. So I'm telling you, this design process you will follow over and over and over again. It never ends. Okay, I know that was a lot. So now we're going to look at the different types of engineering. Okay? Let's go. So the first one is aerospace and aeronautical engineering. Okay? Let's say it together slowly. Aerospace and aeronautical engineering. So aerospace, aeronautical engineering is actually my focus. So I love aerospace and I love aeronautical engineering. So this is actually what I want to do my MS or my master's in. So aerospace, aeronautical engineering, they kind of go together, but they're a bit different. Aerospace like the one on the left with the rocket. Aerospace engineering deals with the different rockets and actual space, while aeronautical, like the one in the right with the two people working on, maybe I think it's an airplane, they work more with airplanes or helicopters and anything that's kind of flying in the sky. Does that make sense? Like aerospace is more actual space, and the aeronautical is more like airplanes and helicopters and stuff like that. Okay? That's cool. If you guys have any questions, please stop me, okay? Because I want to answer all of your questions, okay? So just unmute your microphone and just stop me and I will answer your questions, okay? The next thing is chemical engineering, okay? Let's say it together. Ready? Chemical engineering. So chemical engineering, is kind of where you work with different chemicals, like your soap, like your, I think Lux soap. I think Lux soap is pretty popular, right? Like your Lux soap, your dishwasher or your dishwasher, or like your detergent that you use, like whatever you use to clean your clothes. That's what chemical engineers use. They use different chemicals to make those bar soaps and the different powders or whatever you need to clean your clothes. So that's what chemical engineers do. But there's different branches you could go from chemical engineering. Like you can go into pharmaceutical sciences. So I know it's pretty long, but maybe we can try saying it together. Ready? Pharmaceutical sciences. That's when you kind of look into pharmacy or like different medicine pills. Like the medicines that you take when you're sick, chemical engineers actually kind of come up with those different medicines and those vaccines, right? Like when we had COVID-19, remember? Coronavirus? We needed the pharmaceutical scientists who could also be chemical engineers to help determine the medicine to kill those terrible diseases. That's kind of what chemical engineering is. The next one is mechanical engineering. Okay? Let's say it together slowly. Mechanical engineering. So mechanical engineering is actually my major in college. Like right now, my BS or like my Bachelor's of Science is in mechanical engineering. So mechanical engineering is actually very broad. Within mechanical engineering, I don't know if you guys remember, but remember we went to aerospace? Aerospace engineering is actually part of mechanical engineering. So mechanical engineering is kind of broad, and then within mechanical engineering, you can have like aerospace engineering or like robotical engineering. But mechanical engineering, like overall, is again working with like the different mechanics, like physically building things, like physically building gears or physically building robots or rockets and satellites. That's what mechanical engineers kind of work with. So that's kind of what I'm doing in college right now, and I absolutely love it. I love building things. I love building like robots. Like recently we built a hydrogen fuel cell driven robot. And you guys won't know what it is right now, but that's kind of what we do as mechanical engineering, like actually building the physical robot, which I think is really cool. Okay? Moving on. Up next we have civil engineering. I don't know if you guys remember, but remember when I brought it up before? Civil engineering is where you actually... First, let's say it together. Let's say it together. Ready? Civil engineering. So civil engineers work with the actual physical construction of bridges or buildings and like skyscrapers, like big buildings. Remember the big dam we talked about? Civil engineers are the ones who actually built what we're in right now. Like your classrooms are built by civil engineers. People had to actually build those buildings, your homes that you live in, the hospitals that you go to. Civil engineers take so much time in making sure that our building makes sure that it is above us and it does not crash into us, right? We don't want the building to fall on us, on top of us. So civil engineers work with where the pillars of the buildings will be placed, how the roof should be designed, where the rooms should be, because rooms are designed very specifically. I know, we don't even think about it, but certain rooms are designed in specific areas for certain reasons. So that's a very huge thing about civil engineering, making sure that you're building things where they are supposed to be, like bridges. There's different types of bridges, like there's Warren bridges, there's Warren with vertical bridges, like there's triangular bridges. There are so many different types of bridges, and civil engineers make sure that those bridges are built correctly and making sure that they're perfectly aligned, because we don't want the bridge to fall, because what happens if bridges fall? People get hurt. We don't want that. So that's what civil engineers do. The next one we have is electrical engineering. Remember we talked about this before as well? Okay, let's say it together. Ready? Electrical engineering. Electrical engineering is, again, working with the different electrical components of maybe a robot, a rocket, a satellite. And like, remember what I said before? The big dam? We need electrical engineers to help power those dams, to make sure that the channel's open, right? Because we want the water to flow. In order for the water to flow, we need the channels to open. So we need electrical engineers to help input that power into the dams or the robots, the satellites, the rockets, even your phones. Phones, laptops, huge part of electrical engineering. We need electrical engineers to help with the power and also resistance. Resistance is a huge thing. You guys might not know what it is, but resistance helps with the flow of power in a certain device. Because what happens if we don't do that? Do you guys want to guess? Maybe take like 5 seconds to guess. What do you guys think if we don't have anything to stop the power? It's going to blow up. It's going to burst. It's going to cause fires. It's going to burst. That's why we need the resistance to slow down that power, because what happens if there's too much power? It's going to blow up. So there, electrical engineers have to make sure that our laptops do not burst and burn our faces. So that's why electrical engineering is so important, because without them, laptops won't work, phones won't work. I don't even want to imagine that world. Ooh, okay. The next one is computer engineering. Okay, let's say it together. Ready? Computer engineering. So, I know that some people get confused the difference between computer science and computer engineering. Okay, so let's figure out what the difference is. Computer science is more on the software side. So learning like the different computer languages like Python, C, C++, Ruby, MATLAB, Arduino, AWS, all of that stuff is computer science, right? Like Java programming. All of that is actual code, like coding. You guys will see later on, but that's what computer science is. The next one we have is like what the slideshow is about, or the slide, computer engineering. Computer engineering is more on the hardware side. So you can kind of think about computer engineering with maybe electrical engineering a little bit. So like computer engineering, you work with the actual physical computer, like building the actual computer. So that's what computer engineering is. So computer science is on the software side, right? Like the different languages I get listed, like Python, MATLAB, Arduino, C, C++, all of that. And computer engineering is on the hardware side. So building the actual physical computer. Okay? Moving on. Ooh, biomedical engineering. This is a very interesting one. Okay, ready? Let's say it together. Biomedical engineering. The reason why I said biomedical engineering is so interesting is because it combines two different branches together. It combines medicine with engineering, which I think is so cool. Like the devices that doctor uses, like the stethoscope, or like when you're testing your pulse, your heart rate, when you're like listening to your lungs, like the oxygen mask, all of that stuff, biomedical engineers help design those devices. So that's why I think biomedical is so cool, because they work with different branches like robotics, like prosthetic arms and like prosthetic legs. I don't know if you guys exactly know that, but it's in the picture. It's like building a robotic arm. So like for people who like, unfortunately, maybe they don't have a hand or a leg, biomedical engineers create those prosthetic legs and arms to make sure that those people, are able to have another hand, because, two hands, to be honest, is not enough, right? For all the things that we do, just thinking about it and imagine the people with only one hand, just think about the minimum work that they're able to do. So that's why biomedical engineers are needed, so that you can create those arms and legs that people need. Even like those transplants, like heart transplants, your lung transplants. Sorry guys. All of that is biomedical engineers are needed. So for biomedical engineering, you need to make sure you know both your medicine knowledge, like your biology, your chemistry, your physics, all the medicine knowledge with your engineering knowledge. So you need to make sure that you have those foundations done, because this is a very intricate or like very complicated type of engineering. Okay? And this is a lot. Ooh, next is nuclear engineering. Okay? Let's say it together. Ready? Nuclear engineering. So nuclear engineering is exactly what it sounds like. It's dealing with the nuclear part of maybe a rocket, like missiles, like bombs, like all of that stuff. Nuclear engineers are needed, like looking at fusion and fission. You guys might not know what it is, but like fusion is when you have the different atoms or molecules are combined together. So like in nuclear engineering, when you're creating like a rocket, the nuclear part, or like the fire, like the propulsion part for the rocket to actually launch into space, they kind of work with nuclear fusion, right? The atoms and the molecules moving together to make the rocket launch. And again, dealing with nuclear fission. So like all of those atoms and molecules kind of breaking down, like stars. Like when stars are created, like stars in the sky, nuclear fusion is when the stars or like the atoms are combined. And then nuclear fission is like when the atoms or the stars, the molecules are kind of broken down. Okay? Maybe we should say those terms together. Ready? Nuclear fusion, right? The building. Nuclear fission, the breakdown. Ready? Nuclear fusion and nuclear fission. So the building and the breakdown. So nuclear engineers are needed for that fire, or like the propulsion, or like for the actual rocket to actually be launched into space. Okay? Moving on. Okay. Another one is fire protection engineering. Okay, ready? Let's say it together slowly. Fire protection engineering. Okay? Fire protection engineering is actually not that common. Many people actually do not do this fire protection engineering. Like, I think in the United States, there's only like 100 students. I think that's it. Only 100 students, I think. Maybe in the entire nation that only do fire protection engineering. This was a couple of years ago, so maybe the number has changed. But when I heard a couple of years ago, only 100 people. That's it. So to be honest, if you go into fire protection engineering, you're actually kind of safe because one, it's high in demand. There's so many like fire accidents and like the fires that happen, wildfires. So it's high in demand. And so meaning that you guys will have probably a lot of jobs. I think when I heard it last time, it was about 2 to 3 jobs for one person. So if you guys are interested in fire protection engineering, then go for it. Like fire protection engineering, you deal with kind of studying how fire works, like a fire tornado. If you know what a tornado is, right? Like when it's swirling, you look at how the fire kind of behaves, right? Like how it's moving, how can you stop it, how it's caused. Like there's so many explosions happening, like gas explosions, cars exploding, so many wildfires. So fire protection engineers help protect or help kind of stop those fires from happening. Okay? Moving on. Okay. Another one is systems engineering. Ready? Let's say it together. Systems engineering. So systems engineering is also actually pretty interesting as well, because just like biomedical engineering, systems engineering combines so many different topics like mechanical engineering, electrical engineering, software engineering, and different types of engineering all into one. I know, it's crazy. Like, even again, when you're building a robot, systems engineering, you deal with the mechanical part of the robot. So like the physical, how the robot moves, the electrical part of the robot. So like how the robot is powered, and then the software of the robot, like the coding, right? Because robots don't do things on its own, right? It does what human intelligence tells it to do. Okay, ready? Let's say that word together. Human intelligence, right? You guys probably are aware with artificial intelligence or AI, right? Let's say it together. Artificial intelligence. So artificial intelligence is made from human intelligence. Humans are the ones that create these robots, right? So these robots are artificial intelligence, but they are made from the codes and the different commands that humans give for the robot to make or do. Okay? Alrighty. Moving on. We have environmental engineering. Okay? Let's say it together. Ready? Environmental engineering. So it's exactly what it sounds like, dealing with the environment. So when you're dealing with like hydro plants or solar panels, like solar panels, right? Getting energy from the sun, and like the different plants that we have, like the windmills that we have, like getting engineering from the wind. Like environmental engineers kind of bridge the gap between in the environment and engineering. So kind of like finding, so again, like using solar panels, like energy from the sun, and like the different windmills, right? Getting energy from the wind. So it's kind of what environmental engineers do. Like water irrigation, like again, how water is being flowed or used. Like again, the dam, right? The different rocks that I said, right? That could affect the dam. Environmental engineers are needed to actually see what the environmental condition is of the dam, to see if even having that dam in that location or place in the first place is a good idea or not. Okay? Moving on. Okay, yeah. So those are the different types of engineering. So now we're going to look at the different terminology and the different tools that are needed. So our first one is circuit. Okay, let's all say it together. Ready? Circuit. So I mentioned it before, but remember, do you guys remember electrical engineers, right? Computer engineers? Well, electrical engineers and computer engineers need to use these circuits to make sure that power and voltage is being transferred to the different parts of the computer or robot or satellite that you're doing. That's kind of what circuits are, right? But circuits don't just have wires. They have different types, like they have resistance, they have resistors, they have LEDs, they have different buttons, they have ground, they have like different types of clocks, like they have synchronous clocks and asynchronous clocks. Like, let's say it together, ready? Synchronous clocks and asynchronous clocks. Like when something is being counted up and then the other one's being counted down. It's like 1, 2, 3, 4, 5. I think is synchronous clocks. Not exactly sure. But when you're counting down, I think it's asynchronous clocks. Not exactly sure. But yeah, so like stuff like that, like circuitry, again, electrical engineers and computer engineers will use circuits throughout, like their breadboarding. Ooh, another one is accuracy. I should have put the other one. It's precision. So let's say it together. Ready? Accuracy. Accuracy is so important in engineering. If you are not accurate and precise, then your buildings, your bridges, your robots, everything will be a big disaster. So that's why accuracy is so important. So accuracy, making sure that the point that you are doing is accurate. Like when you're building the bridge, civil engineers need to make sure that the right side of the bridge is exactly the same as the left side. Because when the right side and the left side, even 1 centimeter, even if it's different by 1 centimeter, the bridge will collapse. It will drop. It's going to fall down. It's going to break. So that's why civil engineers have to be so accurate that not even 1 centimeter, not even half a centimeter, not even 1/4 of a centimeter is off. It has to be 101% accurate. Exactly the same. So accuracy is so important in engineering. Okay, ready? Another one is, ready? Let's say this together. Computer-aided design, or CAD designing. Okay, let's say it together. Computer-aided design, CAD. So there's different types of softwares like Autodesk, Fusion 360 or Autodesk 360, SolidWorks. Those are all CAD softwares or computer-aided designs that are used to make 3D models that we will see later. So it's, how do you think like we build like our phones, right? Like the phone cases. These phone cases are made through these computer-aided design. So you kind of draw and build whatever you want to print out or actually make in these softwares. And then you use a 3D printer to actually print out those designs. So that's why computer-aided design is so important when you're looking at the different force, the different pressure, the thrust, when you're looking at where your like how it's being how you see the gears, how the gears are moving. So you kind of look at all of that in these CAD softwares, seeing where the pressure is being made, where the force is being pulled. So all of that you can use because these computers are super smart. They are so smart that they will tell you where the force, like what the force is, what the pressure is at certain places, so you can make all the changes and make sure the design is very accurate and precise and perfect. All right, let's move on. The next one is coding. Remember we talked about this before? Coding is like the different softwares like Python, you have C, like these are the different languages. Just how Telugu is one language, right? Telugu is used to communicate, right? Talk to other people. While coding languages like Python, C, JavaScript, Ruby, AWS, these are all coding languages where humans talk to computers. I know it's crazy. Ready? Let's all say it together. Ready? Coding. Ready? Coding. So, Telugu is used to talk to other people, while coding is used to talk to the computer, right? Otherwise, how is the computer going to know what to do? How is a robot going to know when to pick things up? It's through these coding. You have different if statements, else statements, for loops, while loops. You have these types of commands in coding that humans use, like they actually use the computer to type, and it goes and it's transferred, or it communicates to the robot, so the robot knows exactly what to do. Remember when I talked about how artificial intelligence is made from human intelligence? Well, this is a great example. Human intelligence, our brains, are needed to code or write those specific steps or commands through the different coding languages to communicate and talk to the robot to create that artificial intelligence that we have today. Okay, like ChatGPT, I know is so popular. ChatGPT, OpenAI, all of those stuff are made through coding. Okay, another one. This is very important. Ready? Ethics. Okay, let's say it together. Ethics. In engineering, you have different types of ethics and code. So I guess codes of ethics. Ethics are so important because the number one priority in anything, in engineering, in any single field, even computer science or even medicine, it's the safety of the people. No matter what, your safety of your people that you are helping is your number one priority. That's why ethics is super duper important, and you need to know the different rules for engineering. Like for instance, no lying. You are not allowed to lie to your clients or the people you are helping. If another one is the minute you see a problem, you have to take immediate action, because if you delay it, more problems will happen and more lives are in trouble. So these ethics are so important to know. Just how in real life we have those ethics and moralities, like we have karma, we have dharma. Those are ethics for us, right, as humans, right? The same way we have ethics in our daily lives. Engineering also has its own ethics to make sure that bad people don't do bad stuff. But unfortunately, there's going to be bad stuff. But that's why we need engineers and people like you to stop those bad people, and stop those bad things from happening, and help the good people and follow these ethics. Okay? Another one. It's called calipers. Okay? Let's say it together. Calipers. So you guys know what, you guys probably have a ruler, right? Like a ruler, like a measuring tape. Well, that's what a caliper is. The only difference between a caliper and a measurement tool is that calipers measure really small measurements. Like when you're using a ruler, you might measure someone's height or the length of a book, right? So that you can use rulers for like big measurements. But calipers can be used to measure very small things like screws, washers, like very tiny things like tiny screws. Like if you're trying to find the radius or the diameter, like the length of the screw, you're going to need a caliper, because I'm telling you, a ruler, it's going to be impossible. It's going to be so hard when you're dealing with small screws. That's why these calipers are designed to help with those teeny tiny measurements. Okay? Okay, another one. It's a chisel. Okay? Let's say it together. Chisel. These tools are used to kind of when you're like building something and you have like sharp corners, you use this to kind of, if you don't want the sharp corner, to kind of like scrape off that sharp corner to kind of make it more round, if that makes sense. You kind of use it to kind of shape whatever block or whatever you want to be shaped the way you want it to be. Okay, so like if you have sharp corners, you can use that to kind of make it more rounded. Okay, does that make sense? Moving on. Okay, 3D printers. Okay, ready? Let's say it together. 3D printers. Remember, guys, I talked about the CAD modeling, the computer-aided design? Well, this is where you build your models that you want to print out, and then you print it out using these 3D printers. So you know how the printers that we have to print paper? Well, these printers are different. They're not like those printers that print papers. These printers are so much more advanced, where they actually print out the models that you designed in the computer-aided CAD, the CAD design software. It actually prints out whatever you built in that software. So 3D printers are so cool because these 3D printers is what builds or prints out the prototype. Remember, if you, like, for instance, if we're building like a dam, you can design that dam in the CAD software and then print it out using these 3D printers. Okay, so you kind of see that snake? So that's kind of what 3D printers do. They actually print out that actual object, which is super cool. Okay, another one is sustainability. Okay, let's say it together. Sustainability. Okay. Again, sustainability. Sustainability is so important because you want to make sure that whatever you're building stays for a really long time. Just imagine, right now the house that you're living in, how uncomfortable or how hard would it be if the house that you're staying in, you can't stay in for not so long. Like if you're living in your house for more than 10 years or 20 years, the reason is because of sustainability, making sure those buildings are enduring or going through the harshest weather, like so many floods or a lot of rain. Those houses don't fall down, and those houses are exactly where they need to be. Obviously, there's going to be cracks and everything, right? But we can somewhat fix them, maybe not all the time, but for the most part, you should be able to. But if the actual building completely falls or breaks, then what's the point of building it, right? So that's why sustainability is so important, because you want to make sure that the house you're living in will last for many years, like 20 years, 30, 40, 50, 60, 70, 80, 90, 100. And for even like your next generations, you want to make sure that the house is there. So that's why sustainability is so important. Okay, another one. Okay, we're almost done, guys. I promise you. Almost done. Another one is force, right? Like force is kind of like the push or the pull that's acting on the object. Like for instance, you guys probably have maybe your book, right? Put your book down, okay? Just put your book down. Not too hard, okay? Slightly push it. Very slightly. Well, you guys just performed force. You guys are pushing that book. And when you guys are lifting the book, right? When you're bringing it back to you, you're probably pulling it, right? So pull your books back. You guys are using force to pull it back and lift it to make sure it's back in your hands, right? So it's kind of what force is, like the push and the pull. And you need to have this force because you have the different laws in force. Like you have the different Newton laws, right? Like the third Newton law, like whatever force you put out, the same force comes back to you. I know it's a bit complicated. Like if you're pushing the wall, believe it or not, the wall is actually pushing you back. So if you go to the wall and you're pushing the wall, that wall is actually pushing you back as well. The reason why you're not exactly feeling that is because that force kind of gets canceled, right? It's kind of like a plus and a minus. Like the plus, you're pushing it, and the minus, the wall is also pushing you. So that's why you don't exactly feel the wall pushing you back. But that's what Newton's third law is. Maybe we should say that together. Ready? Newton's third law. Ready? Newton's third law. Whatever force you put, force comes back to you. Like right now you pushed your book, right? The book actually also pushed you back at the same time. I know, it's crazy. Even the smallest push that you did, your phone is actually pushing you back as well. So yeah, even within force, you have the different magnitude or how much force you put in. So like, remember how I said a little bit of force? That's the magnitude. Okay, let's say it together. Ready? Magnitude. The amount or how much force. So very little force, right? Like I said. And then the direction. Like, where is the force going? Like, I told you guys to push it front, right? The direction is front. So let's say it together. Ready? Direction. So, I told you to push it forward. That's the direction. Okay? Let's move on. So that was force. Okay, let's say it together. Force. Okay, yep, that was our last one. Okay, so let's have a quick recap. So first thing we did was we learned about engineering, right? Like what it is, what is exactly engineering, and we talked about, what does engineering actually mean? So remember how we said engineering is where you build things and you kind of solve problems to help the society. So that's kind of what engineering is. We talked about what engineers do, right? Building airplanes, computers, coding, all of that stuff, right? So it's kind of, we talked about what engineers do. We also talked about the engineering design process. Remember the first step, defining the problem and then kind of coming up with different solutions, right? And then the prototypes and then talking with different people. All of that stuff is the engineering design process, like the different steps that we had. We also talked about the types of engineering, right? Like systems engineering, mechanical engineering. Actually, we should say this together. Ready? Let's say engineering design process together again. Ready? Engineering design process. Okay? And then we talked about the types of engineering. Ready? Repeat after me. Mechanical engineering. Ready? Mechanical engineering. Civil engineering. Civil engineering. systems engineering. Systems engineering, right? So we talked about those different types of engineering. We also talked about some basic engineering terminology and tools, okay? Ready? Like coding. Ready? Say it after me. Ready? Coding. Coding. Talked about 3D models. 3D models. We also talked about computer-aided design. Ready? Computer-aided design. CAD modeling. Computer-aided design. CAD modeling. Right? So that's kind of what we talked about today. So I guess some key takeaway and some benefits, like why engineering is kind of so important, is one, you want to help give back to society, right? Our society has done so much to us. Like it gave us water, it's giving us food. We have wonderful people that we're living with, right? You want to help give back to that society, right? Because our society is not perfect, right? Probably in your village too, you probably have so many problems. So you want to help give back to your village or like your society. So engineering is a great way to do that, to maybe help solve water problems, food problems, or house problems, or whatever problems that you find in your village or neighborhood. Another one is you make good money. So you guys make a pretty good amount of money in engineering. Engineering is definitely part of up there. It's definitely part of the top 10. Mechanical engineering, right? Maybe we should say that again together. Ready? Maybe I'm going to choose a different one. We didn't really talk about this, but robotical engineering. Ready? Can say it together? Robotical engineering, right? Robotics, right now, machine learning, I'm telling you, is the right time. I'm telling you, robotics, machine learning, if you take that, you will be in a pretty good position, right? Because right now, artificial intelligence, AI, is taking over, and there's a lot of stuff happening. So you get to make good money out of that. Again, number 3, you get to solve so many issues, right? Again, the water problems, food problems, environmental problems, right? The fire problems. So you get to solve so many issues. And again, highly demand in job markets. There are so many engineering problems, but not that many engineers, right? So there's more problems and less engineers. So that's why it's pretty highly demand in the job markets. So that's pretty good too. All right, so we're going to the end, kind of. I know this one I had a lot of stuff to teach you guys, I know. But do you guys have any questions, comments, or concerns? Like, how was class today? You guys liked it? If I teach again, would you guys like for me to make these type of lessons? Was it too advanced? Maybe you guys could maybe tell me later. Okay. But that's about it. Thank you guys. Thank you all so much. I really do appreciate it. Alright, then just let me know, okay? If it was too much or too little, or if you guys want more of these type of lessons, just let me know. Alright, thank you. It was nice teaching you guys. Bye!